All right, so we got an even split on this one. A slope of 4 inches to 1 foot. Now, most of y'all ask, well, why would I need this? Think about ramps and roofs. You have a slope of 4 inches per foot. Okay? My average All right, so here's what y'all kind of forgot on that one. Can't compare apples to oranges. So 4 inches, how many inches in a foot? So 4 to 12 would be 0.3 repeating. Okay? It's perfectly fine. It happens. That's kind of, like I said, this is kind of why I'm doing this, is to see where everybody is with a lot of this. Because ratios, we do them every day. We don't realize we do them every day. Does that make sense? We do it when we're doing just about anything. Because think about it this way. How do you determine which is a longer drive? Because we know literally what time it takes to do one drive versus the other. But what if we don't need time, we need shorter length? We know that too, right? We do these ratios and proportions in our head all day, every day. You know, when we look at, let's say, cereal boxes, right? You have store brand versus the name brand. And then you have to sit there and compare amounts. Giving you an example, I was looking at Cheerios the other day, and they had like 5 different size boxes. And you would think the biggest box would have been the most cost effective. But if you looked, the amount of product in the actual box and compared the prices, it wasn't. You paid more for less. Yes, you do end up paying a lot for air. It's unfortunately a marketing ploy. So if you have a production rate of 425 parts in 7.5 hours, how many parts am I producing per hour? So if I have a production rate of 425 parts in 7.5 hours, so most of a shift, how many parts am I producing per hour? All right, so it looks like those of you that were able to answer got it right. 56.7 parts per hour. So you'd literally take 425 and divide it by 7.5. Should get 56.7, right? Okay. Anybody remember remember proportions? How to do this? Like I said, guys, there's no right and wrong answers on these. Well, there's right answers, but I'm not doing this for a grade. I'm doing this just to kind of assess where everybody's at. So do not trust the answers, okay? We're going over. The answer is 2. And we'll discuss how you find that, but essentially you would multiply 8 times 1 1/4 and then divide by 5. I'll show you all the technique on that just a little bit better in a few minutes. All right, what about this one? All right, so the answer is 30. You would multiply 100 times 9, which would give you 900. Divide by 30 should give you 30. Now you divide 900 by 30. You multiply 100 times 9 to get 900, and then divide by 30. Like I said, we'll go over all this in depth. Okay. And then last question. I really don't think most of y'all will probably get this one, but just try it out on y'all. Huh? Okay. And I'll show y'all how to actually solve this one once we get there. At the bookstore? Yes, they do. But I know you can at Target, Walmart, or any place else. Okay, so yes, y'all will be able to use calculators on some parts of the test. There is a small portion that I asked that y'all don't use calculators on. A nice little learning tool called Kahoot. Log in, you pick a name, and then you play the game. It gives me kind of data on what people are having problems with, and kind of consider this like a group pre-quiz, just so that I can kind of get an idea of what we can kind of skip over with regards to these PowerPoints and what we need to go in depth to. You know, what has everybody, the first ones we did were fractions and decimals. Do I need to go super in depth into fractions and decimals, or do I need to just kind of skim over and remind everybody what you're doing? Ratios and proportions don't really surprise me, because this one is one a lot of people have a weird time, surprisingly, with. I say surprisingly because it's very interesting to me. We do this all day long. We really do. You can literally do any of these. You compare prices. We compare baseball stats, football scores. You compare things all the time. That's all this is about, is the comparison of it, and how much better are the stats of, what are some football players, guys? I haven't watched football deeply ever, so I'm not too up on football player names, but okay, Tom Brady, and who else? Huh? To Drew Brees, Tom Brady and Drew Brees, comparing their stats. You'll do this kind of stuff all the time, okay? And that's why it always surprises me that ratios, when they're put in the simplest terms to find what you need, a lot of people struggle. It's always been very surprising to me. So you compare by subtracting or dividing numbers, okay? So saving 3 minutes on your drive to school, getting points added to your grade, increasing productivity. How many of you have ever worked a job where they tell you that this is your quotient you are supposed to meet, and this is the time frame you have to meet that quotient? Everybody should raise your hands because we all had to do it. Even if you do nothing but stock product, right? You have to have 100 boxes an hour, right? And the boss comes and yells at you if you don't make that 100 boxes an hour. Sound about right? So we automatically do this. Most of us hate it whenever the boss sits there and goes, you have to do this. And you sit there and ask yourself, okay, how do you want me to do that on top of everything else I've got to do today? So in ratios, the way it's worded is the most important part of a lot of this, because that's what you have to pay the most attention to. You don't look at units, you're looking at, well, I won't say you don't look at units. You're looking to compare correct units to each other, and you're looking to make sure the units you use are correct and what you need them to be. I know it doesn't make a lot of sense, but we'll talk about it a little bit more. So I know most of y'all do not have your books yet. Being said, let me write a few things up on the board for you. First of all, if I have a machine that produces 2,000 parts. Now, here's the thing about word problems. Who hates word problems? Just raise your hands. Raise them loud and proud, because I know so many people hate word problems. I don't ever understand why. All you have to do is kind of go through and pick and choose your data here. Okay? I know a lot of people hate word problems because they start looking at it and go, well, why are there words in my problem? Honestly, if you just start saying it out and try and pick out the data you need, it makes it a lot easier. So if I was to tell you a machine produces 2,000 parts, out of these, 400 parts are defective, what is the ratio of defective parts to total parts? I don't use all that, right? A lot of it is just words. I start picking out what I need. I know I have 2,000 parts. Out of those parts, I have 400 defective parts. Okay? I'm looking for the ratio of defective to total. Have all those words. That's what I picked out. All of a sudden, that makes that problem not seem so bad, right? I think that's generally the issue most people have with word problems, is that it gets to be too many words. Go through and start picking out what you need. Ignore all the rest of the words. I don't need to know that it's a machine that's producing this. I just need to know I have 2,000 parts. I don't need to know that anything else is that 400 are defective. Okay? And then what is it asking me to find? So defective to total should be 400 to 2,000, yes? And this will actually reduce all the way down to 1/5. How do I know that? Start crossing out zeros. Make it 4/20. Reducing from that leads you to 1/5. If I asked for a percentage, it would be 20%. Not so hard, right? All of a sudden, it became a lot easier just by having the right pieces of the data. I don't need all the excess. I just need what I need, right? I tend to find that a lot of people are scared of these because they get confused by it. Now, what if I said instead of the ratio of total to defective, I wanted acceptable to defective? What would that ratio be? Getting ahead of yourself here. I know I have total parts of 2,000. So 2,000 parts. But that's total. I'm looking for how many acceptable parts do I have, which would bring it down to 1,600. And then I have a defective part load of 400. Okay? So the total of defective to acceptable would give you 1/4 once you've reduced, which would give you 25%. So 1/5 of every product run is defective. I think you might need to work on your machine a little. You might want to do a little maintenance, right? A what? Yep. So, like I said, we all do this every day, but sometimes we don't think about how we do it or what we're doing. So, what if we were talking about, here we go. And again, this is all from y'all's books, so go back and look it up once you get them. How many people have gotten the book so far? You got one person? So you got it on order? Huh?
No, I had a question. You know, if I would have put this, I mean, I don't know why, it says acceptable, basically, I would put the 1,600 on top. I mean, that's something, that's kind of a mistake I would have put.
And that is perfectly acceptable. It just depends upon what your boss is actually asking you. And actually, I wrote that backwards. Should have been effective to acceptable. One of those things if I'm trying to write and talk at the same time. It's okay. All right. So there's several different ways you can talk about ratios. It always is about how you express them to your boss as to whether they sit there and look at you and go, why? So out of every batch, you have 1/5 that are bad. I don't want to know. Don't know about you. I don't want to tell my boss that. What I might tell him instead is, hey boss, we have a lot of problems with this machine. We might need to change. We might need to fix it. Please do not ask me how many defective parts we're getting per batch. I do not want to tell you. Exactly. always about how you talk to somebody that gets you through that particular bit. Is everybody good with this particular one? And we'll go on to another set of them. All right. And guys, you probably want to get your books sooner rather than later. Because it is a good thing to have these. So if you work in a plant that uses water in one of its production processes, and it takes 10 pounds of water to create 4 pounds product. So it takes a lot of water to make something, right? Now, I love the picture they use with this. Like, whenever you get your book, you might want to take a look at it because they're talking about an old-fashioned example of such a process. Still, something like that. You're more than welcome to come look at it after class. You may need to use the ratio 10 to 4 in several ways. So what is the ratio of water used to product processed? So I have 10 pounds over 4 pounds. We're doing water to product. Which would end up equaling out to be 2.5, 2.5, or so in order to create my product, I have a 250% water consumption. That's quite a bit. So what if instead we were talking about water to product? All right, so we've got several ratios here. I'm trying to figure out the ones that would make the most sense for y'all. So if you use, I'm sorry, how much water do you use in processing each 10-pound container of product for sale in the U.S.? So product total is 10 pounds. My ratio is 2.5. So I'm using 25 pounds of water. So how much water do you use in processing one day's production of 20,000 pounds of product? You would use the same setup here. You would multiply 20,000 pounds by 2.5. You'd use 50,000 pounds of water to create your product in one day. I hope you're near a big river. Okay? Just some different ways to write some ratios and try and solve them. All right? Kind of skipping through some of these. All right. Put some different things in perspective here. if I had a completion of 6 lessons in 15 hours? How many of you have to do lessons at your job for safety reasons or something? Y'all know what I'm talking about? Sometimes, in order to stay certified for certain jobs, guys, you have to take extra lessons. By that, I mean, let's say if you're in medicine, you have to recertify every year. It takes a certain amount of lessons and hours to do those lessons. At which point, they give you codes that you have to turn around and go use. For those of you that don't know, I've never had to deal with that. So if I do 6 lessons, excuse me, in 15 hours, so what exactly is it asking of me? How much time per lesson? How many hours per lesson? So I would take, you could do it as 6 divided by 15. What would that give me? 0.4. That means for every lesson, spending 0.4 hours at it. Does that make sense? That goes to how much time do I actually have to spend per lesson? Only 4/10 of an hour. Maybe I can get through one more, right? Everybody's all been there, right? Well, it's only going to take a few more minutes. Maybe I can sit through a little bit longer. Let's change it around. Instead of lessons, let's talk episodes of your favorite show. How many of you like Game of Thrones? One person. Okay. What about Walking Dead? 3 to 4 people. Okay. What is the show everybody likes? Oh, wow. Okay. So, okay, before we get into all that, this is how you always verify to yourself that maybe one more won't matter, right? I'm already up. It's past midnight. It only takes 4/10 of an hour to finish one and go for the next. Next thing you know, it's midnight plus plus. It's 2 a.m. and you got to get up at 8. Just one more. That's some better wording, isn't it? Get the idea of ratios, yes? All right. So kind of moving on. All right, so here's another one. Let's work this kind of together. There are 18 students in EET 100. Not really. I think there's about 12 of y'all now. Close enough. On the first quiz, 5 students make an A, 3 make a B, 7 make a C, 2 make a D, and 1 makes an F. Okay? Huh? So what is the ratio of A's to tests taken? All right, so first of all, the question becomes, what is the total number of tests? It's 18. How many people made an A? Double check your number here, guys. Let's take a look at this. Very wordy problem, right? Here's what I need to know. I don't need to know la 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 la. I need to know care what the class is. I don't care about all those words. I need to know 5 students made an A. So I can just go 5A, right? Just cross all that out. More words. Go away. 3B. Cross all those words out. Simplify your word problem. 7. I don't need to know that they're students. I don't care. I know what I'm talking about. Make that word set go away. Need to know 2D. And I need to know 1F. How much does that simplify this word problem? 18 students, 5 A's, 3 B's, 7 C's, 2 D's, 1 F. I don't care about all the rest of those words. They don't make a difference, right? I can even cross out the students here. I know I need 18 total. This is what you should do to every word problem you ever meet. You know why? Because it takes something that is a mental mind game and turns it into something that you sit there and go, huh, that's not so bad, right? Huh? Well, it's not even dummying it. It's just taking out the crap. Excuse me. Taking out the crud. Take out the filler. Thank you. Huh? Exactly. You're taking away all the visual crud. And I'll tell you why. Because studies have been done on this. This kind of is an interesting thing to me, is the fact that human beings can only take in so much. Okay? Now, let's say a big group of people. How many people do you think our brains can mentally count as a group? No, actually, it's very much smaller than that. 5. After about 5 people, our brain starts to give up. And we have to deliberately figure out how to count the people. Okay? That's why a herd of animals, after about 5 or 6, our brain can't keep up with the number, and we sit there and have to visually and physically count the animals. It's the way a lot of people's brains work. Now, am I saying that there's not outliers? Yeah, there's outliers. But the majority of people have a hard time processing hard bits of data if our brain sits there and goes, no, there's just too much here. That's why I say every time you meet a word problem, get rid of the junk. Okay? So instead of having a room full of people, tables, chairs, take all those tables and chairs and get them out of there. Doesn't matter, right? I'm not counting tables and chairs. I'm counting people. And visually, your brain sits there and goes, oh, well, that's a little bit easier. I don't have all this extra junk that's cluttering up my field of view. Does that make sense? So you do the same thing with a word problem. You take out everything you don't need. I don't care how many people are, I don't care about all the excessive wording. That doesn't make a difference to me. What I'm looking for is, what is my total? What is my total of A's, my total of B's, so on and so forth. So what is the ratio of A's to tests taken? 5 over 18. I can see that very clearly now, right? So I have 5 over 18. Expressing that a few different ways, you end up with 5 to 18. If you divide that out, it's 0.278, or 27.8% of the class made an A. Does that make sense to everybody? You lost? Where you lost at? Okay, it's so 18 total students. Only 5 made the A. So you have a 5 over 18 because it's asking for how many people made an A over how many people total. Nah. Just out of 100, how many people would have made that A? Okay? What is the ratios of A's to B's? 5 over 3. Does everybody agree with that? Does everybody see where that comes in? Because I didn't need all this other junk. I need to know I have 5 A's, 3 B's. Right? So I have 5 A's over 3 B's. At that point, I think you're probably starting to head towards probabilities. Yes? Yeah. Yeah. Well, considering that you're rounding. The rules of rounding. Rules of rounding, real quick, guys. All right. 0 to 4, you round up. 5 to 9, I'm sorry, you round down. Round down. You round up. 5 to 9, you round up. I'm sorry. Well, that's the most general rule that I've ever heard, is that start at 5 and up, round up.
They always taught us second decimal, like you said.
Mhm.
If their number was greater than 5, you take it to.
5 and up. Round up. Yeah.
But I never, that's different though.
Really?
4 round down. I just left that out. Yeah, I thought you said something.
Well,
You never know you
that's kind of what I mean by. I always call it round down because it just means that you're not changing the number. You're not bringing it up. You're just leaving it where it is. Does that make sense? In other words, you're not changing the number at all. You're just leaving it where, because it could be. All right, give you for an example. So if I have 2.763, and I'm just looking for these two numbers, technically you are rounding down. When you bring it down to 2.76, you're technically rounding down.
because our numbers are
Because
already.
you drop the number. Because this number gave this meaning. And that number is actually, if you were to write this out, that should then become a placeholder of 0. Does that make sense? So technically, you actually brought the number lower than what it was. Does that make sense?
But I thought when it's like that, I thought that 3.
So technically, I've not changed the value of these two numbers, but the value of this number, since I dropped it off, I have changed the value of the number in total.
That 3 would have 5 or 6.
If I was to round up, it would. Yes. If I was, let's say if I was to round to this place, this would become 2.8. That's fine. I would say do at least 2 decimal places. Okay? For the most part, I think I've got everything set up to do 2 decimal places. So that means you would have to calculate out to that 3rd decimal place to determine whether you round up or round down. Mm-hmm. Okay. All right. So moving forward, what is the ratios to F's in the class? What the heck? What the heck? Huh. Okay, I don't know why it's doing that. F to test is 1/18. I don't know why it does that sometimes, but for some reason it flipped it for me. All right, what is the ratio of passing to failing? So what you're looking at is passing. So passing is anything above an F traditionally. Now there's a reason I say that, and we'll get to it in a second. So traditionally, 1F means that you had one person that failed. Okay? So you would subtract that from your total. So the ratio of passing to failing, you have 1 fail, 17 pass. You have a fail rate of 5.88%, which doesn't sound very good, but it is what it is. Now, Lawson, I won't say it's Lawson. Our department has a higher standard. All right, minimum grade to pass our classes is a C. Now that's just for our department. For most of career tech, I think, is you have to make a C. I don't know. I know there's certain things Pell Grant will pay for and won't pay for. That's a totally different subject. I don't know if it's all of Lawson that holds the pass-fail rate of you have to make a minimum of a C. There are some classes that will let you pass with it, will let you skate with a D. I know that there are. So that's why I'm saying it's not all of Lawson. I know that our side of career tech, you must make a minimum C. Okay? Does that make sense? Okay. So for our version of pass-fail, I have 3 Ds because I have 2 Ds, 1 F. So I have a total of 3 fails, 15 pass, 20% of the class fails. They failed. Because you got a D or an F. Yes, that's a good thing about a lot of the stuff we do is we do drop the lowest test scores and sometimes even lowest quizzes. %, comparatively to the pass rate, not so much to the total, excuse me. So like I said, word problems are nothing to really be afraid of, guys. I know so many people hate them because they just don't understand that all you gotta do, get rid of the junk, right? Just like your garage, right? How many of y'all have a junky garage? And it seems like it would take forever to clean out the garage, right? Or to clean out whatever room is your junk room, because we all have one. You have a junk drawer, you have a junk room, you have some place that is so cluttered you never want to touch it. All you gotta do is start going in and getting rid of the trash, right? So average is a summary of unequal numbers. So if we're looking at this particular one, if Patrick had the following bowling scores, what is his average for the night? Do I really care what the guy's name is? Do I care about anything other than the fact that he had bowling scores, and I'm asking what is his average? Not really. So in this case, you pull all your three of your numbers, you add them up, divide by the total, and you get an average score of 206.67, which is better than I could ever do in my bowling career. For those of you that don't understand what I'm saying, it's that I cannot bowl. I will go ahead and admit that. I can't bowl. All right. So that's just finding an average, guys. You add them up, divide by the total number. And that applies for, I won't say it applies for all grades. And the whole reason I say that is because a lot of people come under the misconception that all grades are created equal. They are not, right? How much are the quiz grades for this class? What is the percentage of the quiz grades for your grade? It's 25%. So not all grades are created equal, right? But if you want to find out what your total for your quiz grades are, this is what you would do. Or if you want to find out what you made on a test, because this is actually how I score your test. No. We tend to hold, if it's test grades, all test grades are equal. If it's quiz grades, all quiz grades are equal. We drop the lowest ones, but no one piece of anything holds a higher standard than the other. Does that make sense? We don't sit there and say, you know, all this other stuff is stuff you don't really need to worry about. This one right here is most of your grade. No, we don't do that. Your final is weighs more than everything, than your individual anything, but that's because it's the final, it's cumulative, and it's really not as bad as what you think. Considering that everything on the final is stuff you've already gone over and taken tests on. We don't add any new material to the final. Yeah, we don't do that. We're not that evil. Yeah. What quiz? Oh, the syllabus quiz, that's part of your first week quizzes and agreements. That's like, those and the other quiz and agreements are 4% of your grade, I think. Yes. It's just saying you agree to the syllabus and going through the syllabus and going through the material of the syllabus. Yeah. There should have been 2 quizzes and at least 2 agreements. Okay? Get them done as quickly as possible. I leave them open all the time so that anybody that wants a better grade on one can go take a better grade on it. Okay? It's under the start here tag on Blackboard. Well, it still is. It's actually a little bit easier. Now they've standardized it across all of us. Anyway, back to what we're doing on calculating grades. This is actually how I calculate your overall test score. Since I give a roughly 2-part test, I give a paper portion and I give an online portion. The reason I do that is because the paper portion is for me to assess where you are having issues as far as mathematics. Does that make sense? I don't make it overly hard. I try and keep it kind of easy so that everybody can give me their best shot at doing the test. We'll do a little bit of review before the test, simply because I'm that nice person. But I add the points from the online portion and the paper portion together. I subtract out whatever y'all missed, And then I divide by the overall total. Okay? And believe it or not, most people like the fact that I give two parts because the online part is literally multiple choice. The other part is you have to actually answer questions. So I'll leave it at that. All right, so that's how you would, well, okay. So moving on to the last part of all this, and that is proportions. How many of y'all remember proportions from, I think, middle school? Yeah, a little bit, middle school, high school, a little bit of statistics, a little bit of that kind of stuff, right? Let me ask you this: how many of y'all cook? A little bit baking, cooking, something to do with food. Or you have to portion things out. All right. Second bit of this: how many of y'all have had to modify recipes because you are making more than the one portion? A couple of y'all. That's all you're doing with this, guys. So to give you for an example. All right. Let's say you're making a batch of cake. Okay. No, better yet, cookies. Thank you. All right. Let's say you want to do 2 bags of cookies. Right? You got the pre-made mixture, and all you have to do is add water and butter. Right? Or if you do something like instant rice, and all you have to do is add water and butter. But you can't just make one portion because maybe you got family coming over. You know what I'm talking about? So instead of one box, you make 2. And in the first box, it says that you need, let's say, 1 2/3 cup water to 1 portion. Well, I'm also making 2 portions. So what do I have to do? Well, I have to ask myself, what is it going to take to do 2? I'm going to have to double my recipe, which should end up giving me, anybody got a clue? 3 1/3. How do I know that? Well, 1 2/3 plus 1 2/3, that would give you 2. 2/3 plus 2/3 is 4/3. So you have 2 4/3. That is actually 1 1/3. So you end up with 3 1/3. So technically you do proportions all the time. Does that make a little more sense? So instead of looking at it as the scary thing you all think it is, let's try looking at it a little bit differently. The first thing you need to recognize is the fact that when you do this, you have to have a certain way you set it up. Now, what do I mean by that? Well, whenever you write it out, let's see, I actually got anything on here that I can work with here. All right, here we go. So a car travels 125 miles in 3 hours. Do I care if it's a car traveling? No. I need to know 125 miles, 3 hours. Get rid of all the junk here. And then I have a question of how far it travels in 5 hours. So I don't really need all this. I just need to know my second part of this is 5 hours. So I pull down 125 miles, 3 hours. Those go together like peanut butter and jelly. Okay? They got to stay together, right? So then I ask myself, the next thing I'm looking for is how many miles to 5 hours. Does that make sense? Y'all see where I'm going with this? what I do is I multiply my miles, my first set of miles, by that 5 hours. So 125 times 5 gives me 625. I multiply the inner sides of these by saying 3 hours, and then I would give this a generic, I'm multiplying by x. Why x? Well, because everybody knows x, right? X is a thing you're comfortable with. If you prefer A through Z and any one of the other letters of the alphabet, feel free to use them. I just end up using X because it's a generic one that everybody uses. Does that make sense? All right, so I end up with 3x equals 625. I would then divide each side by 3. Why? Because what I do to one side of an equation, I have to do to what? Do to the other side. Basic math principle, huh? Yes. So this guy cancels out. I end up with x equaling 625 divided by 3 should give me somewhere around 208 and 1/3. Okay. So in 5 hours, I can go 208 miles, 208 and 1/3 of a mile. Not that bad, right? It's really not that terrible, guys. All right, so I promised I'd show y'all how to solve the other ones we were going over earlier when we were doing the little game. Everybody good with this before I erase it? Okay. I don't know why the Transformers is up there, but we're going to kind of just use this page as a blank page. Okay, so I'm going to come up with a few on my own here. So let's say 25 is to blank equals 60 to, we'll say 7. I'll go ahead and say I don't know the answer to this because I'm pulling it completely out of the top of my head. Let's solve it. That could be worse. All right, so where do I start out? Now, they use the term means and extremes. I just prefer to say I'm going to multiply my outsides before I multiply my insides. Again, I use the generic x. So 60x equals, what is 7 times 25? Huh? 175? And then what would I do? Divide both sides by 60. So I would have x is equal to what? I mean, after you divide 175 by 60. 2.91. 2.91. 2.91. You see what I did? Okay? All right, let's do another one. This time I'm going to pull from the book, and I'm going to do the one that I know everybody got wrong, so we're going to talk about it. So 33 and 1/3 is to 78 equals 4 1/2 to x. Okay? So my process, again, is I multiply my outside numbers and I multiply my inside numbers. Okay? Yes. So 33 and 1/3 x equals, what is 78 times 4 1/4? Huh? 702? Everybody agree with that? Does everybody agree with 702? I know you might be right, but I want to make sure everybody else agrees with it and does their work too. 351 is what you got? Anybody else? Everybody go ahead and take your phone, open it up, and pull up your calculator app. I know everybody has a phone that's got one. Yes? So 78 times 4.5 should give you 351. Okay? So what do we do from here? We divide both sides by 33 and 1/3. In your calculator, you would say that you were going to divide by 33.3 repeating. You should end up with 10.53.
You know what? This is easy. Take it all back.
Everybody remembers what you're doing, right? Because just like cooking and just like comparing two driving routes, yeah? How long is it going to take me on route A versus route B? Well, if I'm going through traffic on route B, I know it takes me X amount of time longer than if I'm just going through it at night.
So when
Right?
you done with the big numbers, like you don't worry about the fraction.
You use the decimal form of the fraction. Or you use, because we are using the fractional form. Because here we used, instead of 4 1/2, we used 4.5 to multiply if you're using your calculator. Now, some calculators can use fractions. Those give you a little bit of about the same result. 351, and then you divide by the 33 1/3. Okay? Yeah, that was. So, You do the two outsides and then you do the two insides. So you use proportion A. So we'll do AB is equal to A1 and B1. So when you multiply this, the way you're technically doing it is A times B1 equals B times A1. So you're doing A times B1 equals B times A1. And one of those is a variable. That's all you're doing. Same thing. Okay? Are there any questions on ratios and proportions or on decimals that we've already gone over? Any questions from anybody? Y'all can take pictures if you want to. I'll leave it up here. But I think we are coming toward the end of class time anyway. So we will be going over powers and roots on Thursday. Make sure you are here on time and prepared, guys. Please, because I'm going to go ahead and give you your first lab. And it's a take-home lab. This one is, most of them will not be. That's fine. Well, let me go ahead and pause this out.